so look. You guys.
Are you a Tom Petty fan?
He's all right.
All right,
Okay. Yeah. All right, so look, there is no picture on these. None of your homework problems are going to have pictures. You're going to have to draw your own picture and go from there. So let's just read it first, and then we'll go to the picture. So you got a hot air balloon going straight upward off the ground, right, at a rate of 4 feet per second. Then you got a camera on the ground 20 feet away that's going to follow and track the balloon as it launches. So what's going to happen here is you're going to have the ground, right? And then you're going to have the ground here. And then you're going to have the camera that's going to have to rotate to keep track of the balloon. Does that make sense? And isn't there an angle formed in here between the ground and the camera? And that's called an angle of elevation. Angle of elevation is the angle formed with the ground. Is that clear? So when it talks about angle of elevation, that's what it means. Okay. So again, the camera's going to have to rotate like that to follow the balloon that's going straight up, right? It's going to follow it. Okay. So anyway, so what we know here again is we know that the camera is 20 feet away from the launching spot, and we want to know at what rate is the angle of elevation of the camera going to be changing at the moment in time when the balloon is 15 feet above the ground. Okay, so here we go. So notice what I drew. Here's the launch spot right here. Balloon's going to go straight up, forming a right angle there. Okay. The distance between the camera and the launch spot is not going to change, as obviously that's always going to be 20 feet, right? But what is going to change? Well, we already talked about this angle of the camera is going to have to change to keep up with the balloon, right? What else is going to change? Well, clearly the distance from the balloon to the ground straight down, that's going to change. So I called it a P. You could call it anything you want, but it is going to change, right? So it's going to have to be a variable. And isn't the distance from the camera to the balloon also going to change? So I'll call that C. Are you following me? Okay. All right, so what are we given? What is this for, guys? That's the rate at what's changing. Yeah, that's the rate at which the distance P is changing. So you're given that. And we want to find the rate at which the angle of the camera is changing. So that's d theta dt at the moment in time when what? When P reaches what? 15 feet above the ground. Got it? Okay. All right, so now look, you guys, the hard part is the equation. This is the tricky part. So please, guys, look up here, put the phone away, put everything away. Everything goes away. Thank you. Okay. All right, so where was I? Okay, so the hard part is getting the equation here, right? Now, what does your equation have to have? Because there might be too many variables here. So only focus on what the equation has to have. The equation has to have what in it? P and theta, right? So it definitely has to have theta. It definitely has to have P, and hopefully it'll have the 20 as well. Otherwise, you might have too many unknowns if you don't include that 20. Are you following me? Okay, so is there any reason to bring C into this right now? Is there? No. So, am I going to use Pythagorean theorem? No. The other reason I don't want to use Pythagorean theorem right now is because Pythagorean theorem doesn't help me with that angle, does it? Theta. So I'm definitely not going to use Pythagorean theorem. Okay? So what are you going to use? Well, take a look again at what your equation has to have. You've got a right triangle here, and your equation has to have theta, and then this side. You guys, isn't P the opposite side of the angle theta? And then we also want the equation to have this side, which is the what? The adjacent side of your right triangle. So at this point, I want you to think about SOHCAHTOA. Okay? So think about the acronym SOHCAHTOA. What that does is it helps you remember that in a right triangle, you can find the sine of an angle by taking the opposite side divided by the hypotenuse. To find the cosine of an angle, you can take the to find the cosine of an angle, you can take the adjacent side over the hypotenuse. And to find the tangent of an angle, you can take the opposite side over the adjacent side. So, which of the three trig functions should I start with here that will involve this angle, its opposite side, and its adjacent side? Clearly, it's what? Tangent. Okay? So, that's what I wrote. I wrote the tangent of the angle theta can be found by taking the opposite side and dividing by the adjacent side. So I wrote that. Everybody with me? Okay, now, you guys, for derivative purposes, please, you guys, please always write something like that as 1/20th p. Okay, for derivative purposes, you definitely want to do that. Is that clear? Okay, so here's where we're at. We got tangent of theta equals that. And now we want to clearly differentiate both sides with respect to time t to get the rates in the equation. Are you ready? Okay, what's the derivative of tangent? Well, secant squared, and then don't you put the inside back in the way it was, which is theta, and then by the chain rule, you're supposed to multiply by the derivative of the inside. So what's the derivative of theta? Well, technically it's 1, you got to put a what? d theta dt, because you're differentiating with respect to t, not theta, right? So you need a d theta dt. Okay, what's the derivative of 1/20th p? Well, it's 1/20th, and then I got to multiply by what? dp over dt, because again, we are differentiating with respect to t, not p. Okay? Everybody with me so far? All right, now the bottom line is I'm eventually going to want to find d theta dt, aren't I? So here's what I'm going to do. You can start putting in things now and worry about solving for d theta dt later, or you can just go ahead and solve for d theta dt now and then just substitute later. So it's up to you. Okay, so this is the way I decided to do it. The first thing I definitely want you to do is replace secant squared with what? 1 over cosine squared. Yeah, you don't want to have to deal with secant. It's easier to deal with cosine, isn't it? So I'm going to change secant squared to 1 over cosine squared. That's no big deal. That's just a simple substitution. With me, guys? Okay. All right. Now, again, like I said, you can start putting in values now and solve for d theta dt later. Or you can solve for d theta dt now and then substitute in values later. It's up to you. I decided to go ahead and right now solve for d theta dt. So doing that, how am I going to do that? Well, I'm going to multiply both sides here by cosine squared, right? And that'll take me to here. With me? Okay, so all I did is I multiplied both sides of that equation by cosine squared, and that gave me to here. And then, you guys, so here's where I'm at. I've got this. And you guys, I want you to write this as cosine squared, like that. Okay? All right, so if I'm going to be able to find d theta dt, I'm going to need a value here, right? And I'm going to need a value here for cosine of theta, correct? Everybody with me? Okay. Do I know dp dt? Yeah, it was given to be what? It was given to be what? 4. Now, take a look at this. What do I need to put in here? I need to put in the cosine of theta. Do I really need the angle theta? No. And that's where you guys are going to make your mistake. You're going to think that you can't do this without a calculator because you're going to think that you need to find the angle theta. I don't need the angle theta. I only need the what? The cosine of the angle theta. And you can find that without ever finding the angle. It is possible. You ready? I'll show you how to do that. So back to my drawing here. The key is this. You're trying to find d theta dt at the moment in time when p reaches 15. So at this point, after you've differentiated, you're allowed to go ahead and freeze that right triangle momentarily at the moment in time when p reaches, what, 15 we said? Are you following me? All right, now again, I need cosine theta to fill in here, don't I? Well, again, according to SOHCAHTOA, how do you find the cosine of theta? By taking what? What side over what side? The what? Adjacent side over the what? Hypotenuse. Well, here's the angle, right? I have the adjacent side. What don't I have? I don't have the hypotenuse. So how can I find that? Well, let me call it C. Can I just use Pythagorean theorem now here to find out what the missing value of C is? Okay, so that's what I did. What did I write? I wrote C squared equals 20 squared plus 15 squared. I didn't show you all the details, but if you solve for C there, you get C is 25. Okay? So I'm now going to fill that in over here and put a 25 there now. And now I can go ahead and finish finding the value of cosine theta. What is it? It would be what, guys? Adjacent side over what? Hypotenuse. And by the way, that reduces to 4/5, doesn't it? Okay? So at this point, I've got the cosine of theta. Okay, and so I can go ahead and put that in here. And then when you simplify that, let's see, 4 goes in there once, 4 goes in there 5 times. And here when I square this, I get 16/25, so I get 1/5 times 16/25, which is 16 over 125, right? And by the way, what are my units on my answer, guys? What are my units on my answer? Well, on top, it should be the units of theta. When you guys are doing right triangle trig, the angle will always be in radians. Okay, so the units on theta are just radians. And then what are the units on time in this problem? Seconds. Okay, so again, there it is. Everybody understand what I did here? Okay? All right, so again, all the details were down here. There was exactly what I just showed you, and ended up with that answer. Okay, guys? Any questions? Okay, let's go to the second and last example of this section. All right, again, there's not going to be a picture on this. You're going to have to draw your own picture to model the situation. But for right now, let's just read it and kind of get a feel for what's going on. Ready? Okay, you got a street light mounted at the top of a 15-foot high pole. And you got a man 6 feet tall walking away from the pole at a speed of 5 feet per second. And what's going to happen here is the light's going to shine over his head and create a shadow in front of him on the ground, right? Okay? And we want to know how fast is the tip of that shadow moving when he reaches 40 feet from the pole. Okay? So, there's my drawing. I know the guy looks more like a zombie, but it's almost Halloween, so that's okay. Okay? So, again, I drew the pole. There's the light at the top of the pole. And what's going to happen is the light's going to shine over his head and create the top of the shadow over here on the ground. So that's the tip of his shadow right there. And then the shadow is going to go all the way to the man. So that is the length of the shadow right there. Are you following me? Okay? All right, now let's talk about what's going to change and what's going to stay the same. What's going to stay the same? Well, the height of the pole is not going to change, so that's always 15. The height of the man's not going to change. That's always going to be 6. But what is going to change as he walks away from the light? What is going to change? Well, if he's moving, the angle at which the light shines overhead is going to change. And when that angle changes, obviously the tip of his shadow is going to move, isn't it? But not only that, not only is that one single point going to move, but I mean, you guys have watched your shadow before. What happens when you walk? Does the length of your shadow change, stay the same, or does it change? If you ever watch it, it changes, right? The length of your shadow does not stay the same. The length changes. So a couple things are going to change here. The spot at which the top of your shadow is at is going to change. That's going to move along the ground. The length of your shadow, which I called y, is going to change. And obviously the distance from the pole to the man is also going to change. You understand? All right, now I want to clarify something before I go any further. What do we want to find? We want to find how fast the what? The tip is moving. It does not say find that rate at which the length of his shadow is changing. Those are not the same thing. The length of his shadow and the rate at which the tip of his shadow are changing, or is changing, are not the same thing. Is that clear? I've got to clarify that first. All right, now, the other tricky part is this. In order to talk about how fast that one point is moving, you've got to talk about, you know, the distance between that and a fixed point. Well, what's the only fixed point we have here? The what? The pole. The pole is the only fixed point, right? So if you want to talk about the rate at which that one point is moving, then basically you have to relate it to a fixed point like the pole. So here's what I'm saying. Basically you have to talk about the whole distance here. What's the whole distance from the tip of a shadow to the pole? What is it? What is it? Well, it's x plus y, isn't it? So if you want to talk about the rate at which the tip of a shadow is moving, that's what you're trying to find, by the way. You got to find the rate at which the whole distance x plus y is changing with respect to time. So that's tricky. Everybody see that? Okay? And so, again, you're trying to find the rate at which that distance x plus y is changing at the moment in time when he is 40 feet from the pole, which means when x is 40. Everybody agree with that? And by the way, what were you given? You're given the rate at which he was walking away from the pole. So clearly you are given dx dt. And why is it positive 5 instead of negative 5? Why? Because he's walking away from the pole. So x is getting bigger, right? So the rate of change would be positive, right? Okay. And before I go any further, guys, I'm going to actually make that easier. You know when you take the derivative of a polynomial, don't you take the derivative one term at a time? Don't you? So when I say I want to find d of the quantity x plus y over dt, can't I just split that up and take the derivative of x and then add it to the derivative of y? So can I just split that up into a sum of two derivatives instead? Are you following me? Okay, so now to answer my question, all I got to do is find dx dt, find dy dt, and add them together. And I'll be done. Are you following me? Okay, now the hard part. Please, all eyes and ears up here. Now the hard part. What equation am I going to use? Well, obviously I want my equation to have x and y in it, right? And I also want my equation to have the 6 and the 15. Otherwise you might have too many variables. So let me ask you a question. Is there any need or any reason to bring the third side, which would be the hypotenuse, into the picture here? Is there any need to bring those in? No, because if you bring in the hypotenuse, you're going to have too many variables, okay? So forget that. So if I'm not bringing in the hypotenuse, I'm probably not going to use what? I'm probably not going to use the Pythagorean theorem, right? Okay? Am I going to use SOHCAHTOA then? No, you'd only use SOHCAHTOA when you need to work with an angle, right? Am I working with any angles here? No. All right, so I'm not going to use Pythagorean theorem. I'm not going to use SOHCAHTOA. Then what am I going to use? What's the only other choice here? Well, take a look at the picture. What do you have? You have this little right triangle inside the bigger right triangle, which means you're probably going to use what? Yeah, similar triangles, right? You understand where I'm going with this? Okay, so I know there are a lot of different proportions you can write. So take a look at the one I wrote. What did I write, guys? I said what? This whole distance, which is x plus y, is to this distance 15 as what? Again, this distance is to 15 as what? Y is to what? 6. All right, now let me say something about that. Could I have done it the other way? Could I have said 15 is to x plus y is 6 is to y. Could I have done it that way? Yeah, but what's the only problem with that? Well, now the variable's in the denominator, and you've just made the calculus a whole lot harder. It's not that you can't use that. It's just going to make the calculus a lot harder. So remember that. So please try and make it easy on yourself by putting the variables in the numerator when you're writing those proportions. Is that clear? Okay, and by the way, can I simplify that or write it another way algebraically that'll make the calculus even easier? Yeah. What can I do to the left side? Break it up into x over 15 plus y over 15, and then turn it into that. And on the right side, for derivative purposes, do you agree I should write that as 1/6y for derivative purposes? Okay, now listen closely, guys, because I want to explain what I did and why. If you want, right now, you could go ahead and take the derivative of both sides with respect to time. Everything would be fine, okay? But eventually then you're going to have to combine some like terms. Okay, so you could do that. That would be fine. But what I did instead is I decided to simplify this as much as I could right now so that when it comes time to take the derivative, that will be easier. Okay, so what did I do to make this easier? I did what? Well, I got the y's on the same side, and then I got a common denominator, and then I put them together under one fraction. So now I'm here. So now all I'm going to do there is just make the calculus easier by doing these steps. Did I have to do those steps first? No, I did not. It's just what I decided to do. Okay? It's up to you. Okay, so now that I'm down to here, I'm going to go ahead and differentiate both sides with respect to t. Everybody, what's the derivative of 1/15 x? Well, it's 1/15, but then you got to multiply by dx dt because you are differentiating with respect to t, not x, right? Everybody, what's the derivative of 1/10 y? Well, 1/10. But then you got to multiply by dy over dt because, again, I'm differentiating with respect to t, not y. All right, so again, it's up to you what you want to do from here. You can either put in what you know now and solve for what you want, or you could solve first and then substitute in later. It's up to you. So let's take a look at what I decided to do here. So what I decided to do here is solve for dy dt. And the reason I decided to do that is because now I have this, and I know dx dt, which is what? It was given to be 5. So I can now just replace dx dt with 5, and when I multiply those and simplify, I get 10/3. So there you go. So I got dy dt is 10/3. Any questions so far? Take a look at it. We're good, right? Okay. With me? Okay. All right, now let's go back to what we were trying to find. Almost done here, guys. What was I trying to find? Well, I was trying to find that, which I said is the same thing as finding those two and adding them together, right? So I think I'm ready to go. So I wanted to find the value of dx dt plus dy dt. Well, what is dx dt, guys? That was given to be what? 5. And didn't I just find dy dt a minute ago? What was it? 10/3. And now I can just add those together by getting a common denominator and get your answer, which is what? 25/3. Now, where did I get feet on top? Well, on top, you're talking about distances x and y, right? What are the units on x and y? Feet. And then on the bottom, you got a unit of time, which in this problem is seconds. All right. Let me add something to this. What if the question said this? Find the rate at which the length of his shadow is moving. What would be the answer? Again, let me rephrase that, or just repeat it. What if the question instead said, find the rate at which the length of his shadow is changing? What would be my answer? Well, the length of his shadow is y, so in that case you would just need to find dy dt. What was dy dt? 10/3. So there you go. So the length of his shadow is changing at a rate of 10/3 feet per second. Got it? Okay. All right. Please, heads up. All right. So you guys, don't worry about the AP problem. I'll give you that another time. So for tonight, you only have 6 problems. And the reason I only gave you 6 problems is because they're tricky. Now, I gave you the even answers, so you can check those. And also, notice, there's no decimals here. So I don't want you using decimals on number 8. There are no decimals here. I don't want you using decimals or calculators on number 24. You can go ahead and use a calculator on 12 if you need to, because it has decimal answers. I'm not sure you have to, but if you need to, go ahead and use a calculator on 12. But again, no calculator on 8 and no calculator on 24. Yes?
Was the 40 feet like basically just a road?
Yeah, it never played a part, which means that the rate is constant and it's not dependent on x. Got it? Okay. Okay, good question. Yeah, so we really never used the 40, did we? Okay, so it doesn't play a role in the rate. Okay? All right, now, two things I want to finish with. I want to do that one problem from last time. It was number 19. But before I go to 19, I want to give you a preview of a couple problems on tonight's homework. In one of the problems, it talks about an airplane flying over a radar station. So here's your radar station. The plane flew over it, and so now it's going away from the radar station. Okay, so there's your plane. And it talks about the distance between the plane and the tracking station, or the radar station. It's not talking about horizontal distance, it's talking about direct distance. So when it talks about the distance between the plane and the radar station, it's talking about the direct distance like that. Is that clear? And so what are the other distances we have here? We have this distance from the plane to the ground. And by the way, it says it's flying at an altitude of 1 mile, which means this is always 1 mile. So that distance from there to there is fixed at 1 mile. Okay, so it's going to fly horizontally. Okay, it's going to keep flying that way like that. So that distance from there to the ground is not going to change. What is going to change, though? What is going to change? This distance, right? So call that anything you want. I'll call it x. This distance, which call it anything you want, I'll call it c. And so in this problem, let me find it. I think this is number 7, if I'm not mistaken. Let me find it. Yeah. Yeah, this is number 7. And it tells you then how fast the plane is moving. Now wait. When it talks about the speed of the plane being 500 miles per hour, what is that? What is that in my picture? If it talks about the speed of the plane, which is flying horizontally, being 500 miles per hour, what is that? That's your what? That's your dx over dt, isn't it? And it's getting bigger, right? X is getting bigger, so it's a positive rate of change, right? That's how fast the plane is moving horizontally. So that's a change in x with respect to time. Then it says find the rate at which the distance from the plane to the station is changing. So what would that be? What? What would that be? dc over dt. At the moment in time when the plane is 2 miles from the station. In other words, when c is what? 2 miles. Got that, guys? Okay, now there's another homework problem. I believe it's number... This is from today. And also from today, assigned number 12. Let's look at number 12 from today. Okay? I'll do the problem from last time with you in a minute. But again, I'm just giving you a little preview of what 12 looks like. 12 has a spotlight on the ground. So this time the light is not on a pole. The light is on the ground. There's the light, okay? And it's shining against a wall. So there's some major differences between the problem I just did and this problem. In this problem, this is a fixed point and the wall is a fixed point. And since the light is shining on the wall, the shadow is going to be on the wall instead of on the ground. So there's your shadow right there. Is that clear? Okay. And you got the guy right here. Okay, so you got a guy walking here, and that's going to shine over his head and cast his shadow on the wall. So in this case, the guy's shadow is going to be on the wall, not on the ground. Okay, do you understand? Okay, so keep that in mind for number 12. Okay, now let's talk about number 19 from last time. And that'll be done, guys. You'll have plenty of time to work today. All right, guys, you have a cone here, right? You have water coming in, forming a cone, right, down here of water. And then at the same time, you got the water leaking out. So you got two different rates of change going on here, right? Heads up. You tap him, yeah. Okay, you got to watch, okay? All right, so let's start writing down what we're given, and hopefully we can figure out what we're trying to find. Oh, there's another problem here, guys. You have different units in the rates than you do in the dimensions. So you got to pick one unit. You got to have all one consistent unit. Do you want meters or do you want to use centimeters? What would be easier, to convert the rates or to convert the distances? It's easier to convert the distances, right? Okay, so that they say the height of the cone is what? 6 meters, right? Yeah? Which is how many centimeters? 600. And then it says the diameter of the cone is what? Well, the diameter is 4 meters, which is 400 centimeters, right? Which means the radius is what? 200 centimeters, right? Okay, guys? And what's changing as the water goes in and out? Well, the height of the water is probably changing, so I'll call that H. And then the radius of the top of the water is going to probably change as well, so I'll call that R, right? Are you with me? Okay, now, what are you given? Well, you're given how fast the height of the water is changing, so that would be dH dt. And what is it? So H is changing at a rate of what? Yeah, 20. Okay, and it's increasing at that rate, so it's positive 20, right? Anything else you're given? Well, you're given part of the dV dt, because it says water is leaking out at a rate of 10,000. So you got a negative 10,000 for the rate of change of the volume, right? However, V is also increasing at a certain rate, which we don't know. So I'm just saying it's going to go up at a rate of R. Okay, I'm just going to use R for the rate at which the water is coming in. Is that clear? So it's going out at that rate. That's why that's a negative rate of change. And then it's going in at some positive rate R. Are you following me? Okay, and what are we trying to find, guys? We're trying to find what? Well, aren't we trying to find the rate at which it's coming in? So aren't we trying to find R? At what moment in time? When what? The height is 2 meters. In other words, when the height is 200 centimeters. Okay? Following me? Okay? Now we need to come up with an equation. What's the only equation we could possibly come up with for the volume of a cone? What is it? What is it? 1/3 pi r squared h. And if you ever forget any formulas, I believe they're all in the front cover of your book. Okay? All right, now let's start talking about what we're going to do before we actually do it. If I were to go ahead now and differentiate both sides with respect to t, obviously on the right side I would have to use a product rule, but when I'm done doing that, I'm going to have a dr dt in there, aren't I? Why is that no good? Why is it no good to have a dr dt in there? Well, because I don't know what DRDT is, and I don't want to know what DRDT is. So that's a problem, right? I don't have a DRDT up here at all. So I cannot have DRDT in my problem, right, in my equation. All right, so that means we're going to have to eliminate R altogether before you differentiate, right? You following me? All right, so off to the side, I want you to get creative and find a way to eliminate R before I do anything else. Well, this should look familiar to you because you should notice you have what here? We have similar triangles, right? One inside the other. So can I write proportions now involving those corresponding sides? Okay, so what can I write, guys? I can write R is to H as what? 200 is to 600. Good. And by the way, 200 over 600 reduces to 1/3, doesn't it? Okay, and now I can solve for R and get that. Or if I needed to, I could solve for H. If I did, I'd get H equals what? 3R? Okay, so which one of these am I going to use over here to substitute in here to eliminate R? What am I going to replace R with, guys? 1/3 H. What if I needed to eliminate H instead? Then I would simply replace H with what? 3R. Does that make sense? So no matter what, you should be able to handle it, right? Okay. All right, now please, you guys, please don't try and differentiate that mess. Why would you want to differentiate that mess? Shouldn't you simplify it first before you differentiate? Okay, so here we go. So let's simplify it. I'd have to square those, giving me 1/9 H squared, right? Everybody agree with that? All right, I just square that, and I get that. Okay, now I can simplify. I can multiply all those and turn it into what? Pi over 27, and I can multiply those and get H what? H cubed. All right, now obviously it's much easier to differentiate. So here we go. We're going to differentiate both sides with respect to time t. Everybody, what's the derivative of v? Well, it's 1, but then I got to multiply by what? dv over dt, right? Okay, over here, to find the derivative there, don't I just leave that alone and then take the derivative of that, which is 3h squared, but don't forget, I got to put a what now? dh over dt, right? Are you following me? All right, now, all right, so let's just start putting in what we know. What do we know now, guys? We know dh dt. What is it? It's what? What is it? 20. Okay, and I'm trying to find R at the moment in time when H is 200, so it's okay to go ahead and put in 200 now at the end, right? And I can replace dv dt with what? Negative 10,000 plus R. All right, and now I'm going to simplify this mess. Ready? All right, I can reduce because 3 goes in there once, 3 goes in there 9 times. 200 squared is what? 40,000. What's 40,000 times 20? What is that? 800,000? And then finally, guys, I'm just going to add that to both sides, and I'm done. And by the way, you do need units because this is a rate, right? What are your units? Well, your units on top would be the units of volume, right? Which would be what in this case? What would it be? What would it be? Centimeters cubed over unit of time in this problem, which is what? Minutes? Okay, guys?